Hey everyone, welcome to this video all about regular expressions or regex. I wanted to dive into really how we can think about using these because they're so powerful and they look initially really intimidating, but once you get to understand some of the key characters, some of the key formatting, they're really not that bad. As always, this is useful. A like and subscribe is appreciated. Now I can use regex in nearly any language. I can use it in things like SQL. I can use it in KQL with log analytics. Pretty much any environment we're working in, we can use this regex format. And we use it for a number of different things. The whole point is I have this ability to define some pattern using text. And then I can use that pattern to maybe check if that pattern is present in a string. I can maybe use that to extract elements or even replace elements. Now, that means it's really useful to maybe validate certain formatting. I could use it to scrub. I could use it to extract parts of a log file. I could scrape parts of a website. There's really a huge number of different ways I can use this. Now, I'm going to demonstrate this in PowerShell just because that's something I'm very familiar with, but I can really use this with anything grep, egrep. If I'm using Linux, for example, you can just switch this out. I am using this environment instead of my whiteboard because basically I just want to do a whole bunch of demos to really show all of this in action. So let's jump in. Now, firstly, I'm just going to define a $string variable. The quick brown fox jumped over the lazy dog. This is one of the first things you learn to type because it's every character on the keyboard. Now, ordinarily, I would use -match, but -match is case insensitive. So just to demonstrate, in case I want to mess around with the casing, I'm going to use cmatch, which is case sensitive. So I don't want it insensitive. Now you can see, first of all, I could just start off with this idea of, well, here my regex expression is just the word fix. It doesn't have to have any special characters in it. I'm just looking for, hey, do I have fix within this string? And so if I run this right now, well, my answer, as you can kind of see down here, is false. It does not find that match. Whereas if I run it and I try and find the word fox, well, yes, it does find the word fox. But we can be a bit more sophisticated than that. Maybe it's just not some set word that I'm actually looking for. So the first useful thing we can use here is the period character, the dot. And that represents any single character. So for example, here, instead of doing fox, what I'm looking for is F period character X. So this means I could have any character between F and X and it will find a match, except a new line. So if I push F8 to run this, well, true. It finds because F anything X, fox, would actually match that. Now note, if I changed it to FOOX in this example right here, and then try and match on F.X, well then it fails because it can't find F and a single character. So this is really stressing the point that period character is any one character, but it's not going to work if it's multiple characters. So it's just looking for one particular, any character in that pattern. So here I was saying, hey, F, any character, X. That's what that was doing. So we can see that worked if it was F something X, but it doesn't work if there were multiple characters between the F and the X. That's kind of the key point of that. Now, maybe I want to be a bit more specific for a particular character. I don't want it to be anything. I want to be able to define, well, here are the things it could be. So this is where we can now go and leverage this idea of a character group. So it's the square brackets and then the characters that it can be between those square brackets. Now it can only contain one of them. So in this case, I'm saying, well, it's F and then either an I or the O character is my regex expression. So that obviously means, well, fox or fix would be matches for that. So, hey, can we fix it? and I'll try and do a execution. Sure enough, it's true. It finds a match. If I change that to Fox, it still matches it. If I change that to Fax, well, now it's false. So that's showing, hey, I'm now saying it'd be one of those characters, but it couldn't be both of them. If I try and do FIOX, then it's going to fail as well. So it's one of the characters in those square brackets. So I'm defining a character group. It can be one of them. And that's really the key point of this. Now, what about if I want maybe some alternate possible characters that make up a word? For example, maybe it's John, but some people spell John John. Some people spell it Jon. And I want to be able to match on either one of those things. So what I can do here is a group. So I use the parentheses characters to define a group. So my regular brackets. And I want it to be either Jon or John. So it's always going to be Jo. And then what I'm specifying is either N or HN added to the end of the Jo. So I'm defining a group with the parentheses, and then I'm using the bar character for or. So it could be N or HN. So that's what we're doing here. So now if I try and run a match on this, well, yes, John Saville matches because it's Jon. Jon Saville, John Saville, matches as well. But if I was to do JOH Saville, well, that fails because neither of those combinations match JOH. Now notice, what if I try to use those square brackets? What happens if I use that on that JOH? Well, it's true. It matches. Why is that? Because remember, what is the rule? If a square bracket, it's one of the characters. So what my rule is really saying, if I was to use the square bracket, is either it's the character N or it's the characters H or N. So JOH matches that. So that's why we use the parentheses and not the square brackets. I want it to actually use those groupings. So it's either N or HN. So I'm defining it that way. Now there is an inverse of the character group. I can actually change it, kind of the up arrow character here, to say mustn't contain these characters. So it could be any character as long as it doesn't match X, Y, or Z. In which case, if I was to run this, sure, it's true, because that's the quick brown fox, FOX, is not X, Y, or Z between the F and the X. So I can say not in a group. So if I was trying to do some regex expression, I wanted to make sure I didn't have certain characters, well then I can use the kind of up arrow character here to say I don't want that particular character. So I have that capability right there. Now, in addition to naming all the characters I want, A, B, C, I, O, whatever, I can do ranges. So in this case, I could say, well, actually, I'll match anything as long as it's lowercase a to z. So notice, instead of just listing a number of characters, this time I'm using a range, A to Z. So of course, that's going to find a match because all of those lowercase letters in my FOX, O is between A and Z. I can even define multiples. So here I'm saying it's an F character and then something between A and Z and then another character between A and Z. So well, that matches as well because FOX is an F and then a character between A and Z and then another character between A and Z. So I can put multiple of those kind of character groups together as part of my regex expression. It's very, very flexible. As you're going to see, I can really combine these in any way I want as I go through these various things. Now, additionally, I could say or. So I'm going to use that bar character So here I've got an uppercase O in my Fox. So if I'm trying to match it, well, it's false because my range, remember, is A to Z, and I'm using the case-sensitive match here. So my result on looking for F, then same between the range of A and Z and X, is going to fail because of my uppercase O. So what I'm now going to say is, well, tell you what, it can be either the range A to Z, or it can be the range A to Z uppercase. So now if I run that check, well, it's true. Because yes, F uppercase OX matches that second. F0X, well, I could say or numerics, 0 to 9. And once again, that's going to match. So all of those work. Now, I put this as different character groups and I ORed them. I don't actually need to do that. As we can see here, I can quite happily put multiple within my character group. Lowercase a to z, uppercase A to Z, and then 0 to 9. Remember, it's any character that matches within the character group. I could type in A, B, C, D all the way through to Z, then all of them uppercase, then 0, 1, 2, 3. I could do that. I can mix in ranges. It's very flexible how I want to use that. So this time I just put all of the possible ranges in that single character group, and that's totally fine to do. So if I was to run this, it's true. It finds that match. If I was to change that to fix, lowercase, uppercase, it matches. If I was to change it to lowercase, it matches that as well. So I can see I've got those multiple things within it. Now in this case, there's some special characters. So we'll see this. So when I'm using my regex, what I can do is a backslash lowercase w. So a lowercase w is any word character. Lowercase and uppercase A to Z, 0 to 9, and the underscore character. So this time in my regex expression, I'm doing F backslash W X. So Fox matches. Same thing against my string, matches. So whether that was F0X, FOX lowercase, FOX uppercase, doesn't care. It's going to match because that slash W is any word character. Now, what if I want to be a bit more specific? So I had my string. Maybe what I actually want is I need to make sure it starts with a certain thing, or maybe make sure it ends with a certain thing. So various types of anchors we can use in our regex expressions to specify, hey, I want to find this at the start. I want to find this at the end. So in this case, this little uppercase arrow character means at the start of the string, the start of the thing I'm comparing it to. So, hey, I want to find Fox at the start. So my string, the quick brown fox, is false. It does not match. But the word the does match because that's at the start. So even though fox is found in the quick brown fox jumps over the lazy dog, it's not anchored at the start. So that's going to fail. Likewise, I can use the dollar character for the end of the string. So that's also an option available to me. So I can say, hey, I want to now match at the end of the string. So that's also another option that I can use for that. So in this case, hey, I want to end with the word fox. Well, the quick brown fox jumps over the lazy dog does not match on that, but it does end with dog. So dog dollar says it needs to end with dog dollar. Great. I find a match on that. So that's how I could look at the start, at the end, and I could combine those together. If I want to be very specific, I could say dollar, my regex, uppercase, upper arrow, my regex expression, dollar. It has to match exactly that. Maybe I want to search per word. So there are various delimiters that separate different words. It could be a space, it could be a tab, etc. So rather than trying to do the arrow and the dollar, I can say, well, look at each individual word and let the regex go and work out where the new words start. And the way I can do that is, well, let's see it not doing what we want. So here I want to find the word for. So very reasonably, I'm looking, my regex expression is just for. So I'm looking for the aforementioned word string. So it doesn't contain for. Does it contain it? Well, sure, it's true. Because for is found in the middle of aforementioned. But maybe what I was actually doing, I wanted to find the word for. So the way we can do that is we can use the \b. So this time, if I wrap my regex with /b, then it will find it as a word. So now it's only going to match if it's just the word for with no other characters around it. It can only be word delimiters at the start or the end of that word for. So that's a failure. But the for word is true, because in this case it's spaces on either side of it. So if I want to search each individual word for my regex expression, then I can use the \b. So it's going to give me that capability. It's a word boundary. And I can still combine that with other things. Remember, the period character is any character, so I can still wrap that as part of my b, and sure enough, hey, it's true. The for word matches because it's f something r, and I find a match there. Now this time, let's combine some more things. I want to find a sentence that starts with the word the and ends with the word dog. Okay, so it starts with the, ends with dog, anything in between, I do not care. So if I look at what I'm going to do here, I'm now going to combine a few things together. So firstly, well, it needs to start with the, so up arrow the, it needs to end with dog, dollar. So that takes care of those things. And then any characters in between, as many as it wants. So what I'm going to do here is, remember, the period character is a single character, any character. And then I'm doing plus. So what plus does is it's one or more of the preceding. So because, in this case, it's dot plus, it's one or more any characters between those things. So if I do a check on that, my match is true. Because sure enough, the quick brown fox jumped over the lazy dog. All those characters in between the and dog were taken care of by the dot plus. If I try that on test ending in dog, well, it fails. It didn't have the at the start of that. So I'm combining these different things together to check I'm getting what I want. Likewise, hey, I want to start with the letter A and end with the letter G. Any letters in between? Sure enough, that's true. Dot plus, one or more. So it could be B, it could be B, C, D, whatever's in between, it doesn't care. That's all it's looking for. Now, if I want that test to only be John, for example, or John, back to that earlier example, remember, I can just combine those things together. So I want the start to be J-O, I want the end to be either N or HN. So that works. That works. That doesn't work. It doesn't want to see Savile at the end. It has to end with N or HN. So that's where I can start to combine some of these different things together. So it has to start with JO, and then it has to end with either N or HN. So once again, I'm combining those different expressions in my regex expression together to do exactly what I want. I can make it as sophisticated or not as I need based on my requirement. Okay, so that was one or more. It had to have one or more, in this case, dot, any character between it. I can also use the star character, wildcard character, depends where you are, what you call this. That means 0 or more. So it's just like the plus, except plus is one or more. the asterisk is 0 or more. So it might be there's nothing in between it. So this time the A, B, C, D, E, F, G match on A starting with, G ending with, so it's the same as before, but this time I'm using the asterisk character with the dot. So any character 0 or more. So this means, obviously, sure, that A, B, C, D, E, F, G matches. Starts with A, ends with G. It's got 0 or more in between. If I just do AG, well, that still matches because it starts with A, ends with G, and it's 0 or more, in this case 0, any characters in between. Now, if I try to use the plus on that, which remember is 1 or more, it fails. Because in this case, there isn't 1 or more any character between the A and the G. If I made it ACG, then it's true again. So that's the difference between the star character and the plus. Star is 0 or more, plus is 1 or more. So that's where we really see the difference between those behaviors. So depending on what I need and what I'm checking for, that's really useful to be able to have that distinction. Okay, so let's keep going. There's also question mark. So question mark is 0 or 1. It can't be more than 1. It's 0 or 1. So if I do my AG, and this time dot question mark, I could have 0 or 1 characters between the A and the G. So AG, yep, because there's 0. ACG, yep, because there's 1. A, B, C, D, E, F, G, no, because it's more than 1 character between the A and the G. Now I can be more specific. There are quantifiers. So what I might want to say is, well, actually, rather than it being 0 or more, or 1 or more, or 0 or 1, I want a specific number. I want 5. I want 4. So here, I'm going to kind of use these squiggly brackets, then I can specify an exact number. Or I could specify a minimum I want, or I could specify a minimum and maximum. So in this case, A, B, C, D, E, F, G, well, that's 5 characters between the A and the G. So this time I'm saying that dot, the period character, and I want 5. So it can be 5 any characters between starting with A and ending with G. So I'd expect this to work. It's true. But if I now added in some non-correct sequence-wise, but if I added in H and I, well, now it's false because there's too many characters. It's not 5. Now I could change this. I could add in a comma, which is saying I need at least this number, but it can be more. So now if I execute, it's true because it's more than 3 any characters, that period again, between A and the G. But if I try just A, B, C, G, i.e. 2, it's false. It's not 3 or more. Likewise, I could set a minimum and I can set a maximum. Minimum of 0, maximum of 5. Okay, that's true. Hey, here I've added in extra characters. It's false. Here I'm saying minimum 3, maximum 5. Well, that's true. This is too many. This is not enough. So you can really start to see all these things come together. And I'm still using that arrow for the start, dollar for the end. So I'm defining those parameters as part of what I want for my regex expression, and then what I want in between them. Now, I could be saying, well, actually, I want digits. Now, I could do the square bracket, as we saw before, and I could say 0 to 9. Or, just like some of the other things we've seen, there's a special escape for that. I can do \d. So \d is a digit. So I'm matching digit, 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 dash character, digit, digit, dash character, digit, 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 or the format of a social security number in the US. So if I try and compare this, That's true. Here there's an extra character in the middle. That's false. It doesn't match the pattern. Here I've replaced the 8 with an F. So it's not a digit, a decimal. That's false. That works. I'm validating it matches that format. But it's kind of ugly. Well, let's use that with our quantifier. So here I'm going to just say, hey, remember my quantifier? I want 3 digits, 3 decimals, then 2 decimals, and then 4 decimals. And remember, each of those groups are separated by the dash. So 1, 2, 3, dash 4, 5, dash 6, 7, 8, 9. Fantastic, it's true. Oh, this one is got an extra digit at the start. Wait, that's true. That doesn't make sense. Why is that matching when I've got an extra character? Remember what we're doing. Remember what this regex is saying. I've got no upper arrow at the start, remember. It's just looking for 3 numbers, dash 2 numbers, dash 4 numbers. Well, in 1, 2, 3, 5, there are still 3, dash 2, dash 4. I just ignore the first. So what it's matching on is this. So if that's not the behavior I want, then I can do different things. Now I'm going to solve it by looking at the start. So I'm adding in that upper arrow. So we do F8. That's false because there's too many digits, but then it's true when I remove it. I could have used the slash B. I could have used the word. So depending on the format of what I've got coming in, I could use different things to actually go and search and find my match. But realize sometimes it may not behave as I expect because I've not been specific enough in my regex expression. Sure, I'm looking for 3-2-4, but if there was 5-2-4 or 5-2-8 numbers, it still matches. It still finds what I want in between that larger thing. So I may need to be more specific with how I break up, with how I consider a successful match of that. Now, sometimes I want to do maybe cleverer things. So I want to find a match. And if I find the match, I might want to change the data. For example, data masking. If I find the social security number, I actually want to hide all of it except maybe the last 4 characters. So what I've got here is I've got a social security number just in the string. And this time I'm going to use replace. Now what my regex is doing this time, once again I want to find 3-2-4. But notice I've added in this idea now of a group. I've put a group in for the last 4 digits. And the reason is when I put it into a group, I can extract that and then use it in another way. So what's going to happen this time is, well, it will take the last 4 and keep it as a group that I can then reference and use. So what I'm going to basically output and replace is change the first 3 and then the 2 with xx-xx and then the actual last 4 characters. So if I spit this out, notice what it's done. Sure enough, it's replaced that social security number. And it will do it with multiple. I'm just saying replace this format. So in this string, I've got 2 social security numbers present. I've got kind of one here and then another one. Well, it will replace them both. If I execute, sure enough, it replaced both of those because it went and extracted the group. So I can start to do some really powerful things with this regex. So it's not just about maybe validating something's there. I want to maybe extract a part and maybe send it to another log file or something else, or maybe even replace the data because I want to mask something. Maybe it shouldn't be in there. So I can start to do other things I want. Now, when we talk about those groupings, kind of what's happening there behind the scenes, I've introduced this concept of, hey, I created a group for those last 4. So a hash table gets generated. and they're numerical by default. So if I now put a group around each of the 3 elements, so in this case you can see I've created 3 groups because I'm using the parentheses around the first, the second, and the third. So it should create 3 groups. So I execute this. So in PowerShell, I get to look at $matches. And what we can see is, well, there's the first match, the 0, is the complete match. But then it breaks it into that first group, the second group, and the third group. So array start at 0. So the 0 was the entire match. And then because I defined those groupings, I have the next number available, which is 1, is that first group, then the second group, then the third group. So now I have the ability to extract and go and do things with those elements. So if I want particular parts of my regex expression matching to be available to do something with, then I can use those groups. Now realize there is a slight performance expense when I start doing this. So don't create those groups if you don't need them. But if there is something I actually want to go and extract, hey, I can use the groups. Now later on, we'll talk about the idea, well, maybe I need a group to my matching logic, but I don't want to actually be able to extract it. So there's another thing I can do, and we'll talk about that if I need a non-capturing group. I can do the same thing. I want to check for a valid email address. Now this is super lazy. This is not the best way to check for an email address. But I might argue, well, do you know what? A valid email address is, well, it has to start with. So I'm assuming my data is the entire object I'm comparing it to. So I've got my little up arrow, and then any character that's A to Z, lowercase or uppercase, and a number. Again, this is not accurate, but I'm looking for that. And then what I'm doing is plus. So remember, plus is 1 or more. Remember, we have our different options here. So we went through all of the different types of checks that I could do in here. So I had plus is 1 or more. Remember, we also had the wildcard, which was 0 or more. So I want at least 1 character. So I'm saying I want 1 or more. So plus is 1 or more of the preceding character groups. So it could be 1, 2, 3, 4, 5 characters. Then I want @ symbol. Then I'm doing another character group of just the letters, and again a plus, so it's 1 or more. And then I want a period character. Now again, this is not valid because it might not be .com. It could be .co.uk, so there'd be another period, and my check I'm doing here wouldn't work for that. This is not good. It's just for an example. Now notice though, I've got a backslash and then the period character. Why? Well, remember the period character is a special character. It means anything. So if I just did a period character, it's not going to work. It's not looking for a period. So I have to backslash. I'm escaping it. So backslash dot means a regular character dot, not the dot that is any character. So I'm saying I want specifically the period character. So I want something at something dot something. And I'm using the dollar to say it has to end. So it's only going to check for those specific elements, and that's all that can be there. So john@saviltech.net, and this isn't my real email, so don't try and mail me on this, it won't work. Well, that matches, it's true, because it's John. So John matches this. Then I've got the @ which matches the @, then Saviltech, well, that matches this part. Then it's dot, so the dot matches this part. And then net, which is, oh, didn't mean to do that. And then net is this part. Remember, the plus is 1 or more, and then it ends. So that matches. But if I did johnsaviltech.net without the @ well, that's false. If I did john@saviltech.net without the period character, that's false as well. So I'm forcing in those specific elements to make this match. Now remember, if I took this first one, for example, it's true. And if I looked at matches, there's a match. It's john@saviltech.net. What if I wanted to be able to extract certain parts of that out? Well, we use the capture groups. So this time I might match, and what I'm using is, well, I'm using parentheses around the part that I consider the part before the @ sign, maybe the username, and then I'm capturing the complete domain part. So the any characters dot any characters, that's going to be a particular character group. So if I run the same command again, it's true. And then, hey, it's John from saviltech.net. And if I just dump out my matches, so the whole sets of them, hey, I can see, yep, 0 is the complete match. And then John is the first custom one I created, array item 1. And then saviltech.net is array item 2. So I'm using those capture groups to get particular parts I care about. I'm defining the parts I care about using the parentheses. I can name them. It's a hash table. It doesn't have to be 0, 1, 2, 3. So what I can also do here by using the question mark, angle bracket, label, close kind of angle bracket, this, I can name the particular part of the capture group. So I'm naming the first part user and I'm naming the second part domain. So I'm just putting that at the start of my capture group. So I'm opening the parentheses, then I'm adding in my label, my tag for this particular capture group. So I should now have, hey, 0 as before, but then I should have in my hash table, instead of 1 and 2, I should have user and domain. So if I execute this, sure enough, my hash table actually now is, sure, there's 0 as it was before, but now I have user and domain based on those labels I specified. So once again, I can really play around and do all these things. And I should stress this file, I meant to say something at the start, it's linked in the description below so you can play along and you can try and modify this however you want. The official regex for an email address is this. This giant thing here is the regex for an email address, which is why I didn't use it. I got zero design to mess around and try and go through that. But if you're really bored one day, you can actually start to see what it's doing. Oh, look, any character A to Z, 0 to 9, and then these various characters it supports, all these different things. You can actually see what it's doing. There are some special characters. We talked about some of these already. They have to be escaped if I want to use them. For example, the square brackets, the backslash. If I actually want to match on that, I have to escape them. So here my demo string is square brackets part something square bracket backslash part square bracket. So if I actually want to match on those things, notice what I have to do. Well, firstly, I have to escape out the opening square bracket, so it's treated as just a character open square bracket instead of, hey, I'm starting a character group to compare to. I also have to escape the closing square bracket. Then I'm creating a character group, I've got a parentheses here, of 0 or more characters, so it's the wildcard, question mark. That will make sense in a little bit, why I've got a question mark at the end of it. And then I've got an open square bracket, which again I have to escape, so I'm escaping it. And then I want a backslash character. Well, I have to escape the backslash character as well by doing a double backslash. So backslash open square bracket backslash backslash is saying, hey, I just want the character open square brackets backslash. That's what that's doing. That's why we have that. And then, hey, backslash close. So I want to search for that. So all of that together is true. It finds a match. And look, there's something in between part square bracket. So that's what that part did. Let me extract from that particular syntax I made up, the square brackets. But that's how I can use those things. Now there are also things like /t for tab, /n for new line, /s is any white space. Imagine I wanted to maybe remove white space. So what I'd be wanting to do here is I've got a string. So my string right here is actually made up of a space, a tab, then some text, and then some spaces and some tabs. It's a mixture of both. So what I want to match on here is I want it to start. So I'm looking at the start. And then it's /s wildcard. Remember the star asterisk 0 or more. So 0 or more whitespace characters. And then it's creating a character group of, well, this is interesting. So then what is it doing? It's a character group. So it's a square bracket. So it can be either /s or /uppercase s. /uppercase s is any non-whitespace character. So what it's saying here is 0 or more whitespace characters and then a group of whitespace or non-whitespace characters, 0 or more. And then at the end, whitespace characters 0 or more to the end of the file. The whole point of this is what I don't want to do is only be able to have letters. I might have a sentence because obviously there are whitespace characters in what I'm trying to compare it against. Remember, I have whitespace characters between whitespaces need and need to. So it's going to look for any whitespace until it comes to a non-whitespace character. And then it's going to keep all of those until it then comes to only whitespace characters again. So if I look at this and I execute this command, it finds a match. And what I'm doing is now outputting the match, but I'm adding a dash to the start and the end. So you can see it did get rid of all the whitespace. It's just dash whitespaces need to go. I could also, instead of using /s, I could have used a space character and /t, /t, which is the tab character. And that's going to do exactly the same thing. So I could either use /s or I could do space /t, which is spaces and tab characters. I was just using a more efficient means. Now, a few times now, you have seen me, I talked about the asterisk, that 0 or more. Then there's a question mark after it. Now, why? Why is there a question mark after it? The question mark is making it lazy. What does that mean? So by default, a lot of the things we're using, like the plus and the star, the asterisk, they're greedy. It will extend the match as far as it possibly can. But I don't always want that to happen. Maybe I want it to do the minimum amount of matching it possibly can. Otherwise, it breaks what I'm trying to do. So I'll give you an example. Let's go back to our white spaces need to go. Remember, what I'm matching on is white space and non-white space. And then I want it to go and find spaces and tabs. But a space and a tab is part of what we're matching on. So if I just did my star character here without the question mark, it's greedy. It's going to go as far as it can. So if I run this command, it didn't get rid of the trailing white spaces. They're still there because it was greedy. Those preceding spaces and tabs are still part of what it was trying to match on. The fact that something later in the regex wanted it, it doesn't care. It's greedy. It's going to take everything it needs. So the whole point here is by adding the question mark, it makes it lazy. It will take as much as it does to get the job done, but it will give up characters to other parts of the regex expression. So when I added in the question mark, what the question mark does is make it lazy. So it's going to go and grab all the non-white space and white space characters it can, 0 or more, but it will be willing to give some up because it's been made lazy with the question mark. So later on, when it's looking for, at the end, 0 or more spaces or tabs, even though those spaces and tabs are what it is looking for earlier on, it's going to give some up. It will give up as many as it needs to for this to do its job. So that's why we have to make it lazy. So it's important to understand sometimes we don't want it to just take as many as it can. We want the rest of the regex expression to succeed if we can, so it finds the match. So make it lazy, say, hey, take what you can, but be willing to give up so other things can be successful. So it's kind of an important part of what we want. So we can see that again. 1 to 9, match on. 0 to 9 as a group, so we're putting it in the parentheses right here. And then 0 to 9, 0 or more. So what happens if we run this? Well, it finds a match. And if we look at what it matched 1 to 9. So even though the bit at the end would have took some, there was nothing left for it at all. What about if we make it lazy? So if we do exactly the same thing again, but this time, remember plus is 1 or more, but we're going to make it lazy with a question mark. Because remember what comes after it is, hey, I'll take 0 or more. So let's run it. So now we've made it lazy instead of greedy. If we look at matches, it's a single number because it's now lazy. It does the bare minimum it needs to help make this successful, but it gave everything up to the second part. If we looked at just our matches, remember, hey, it matched on the whole thing, but that group we specified just took 1 because it was a plus. So to be successful, it needs 1 number. Okay, I'll take the first one, then I'll give the rest of the expression. Now, even greedy will give up characters for a match if it's required. It does something called backtracking. So in this case, the 0 to 9 star, it wasn't required. It could have a number, but it was the asterisk. It's 0 or more, so it doesn't need any. But this time, my expression, my regex is, well, 0 to 9, 0 or more, and then I must have 2 numbers at the end. Now remember, I have no question mark, so this is greedy. However, even though it's greedy, it still saved 2. Because this specifically wanted 2 at the end, even though it was greedy, it will give up to help make the regex successful in this scenario. What if I don't want that? Well, I can make it possessive. I can add a plus. So if I add a plus to it, so in this case, asterisk plus, then it would not give up. Now, I'm using PowerShell, which is based on .NET. .NET does not support that possessive. What I can do is I can use atomic grouping. So it's question mark, right arrow. That removes backtracking. So now if we use exactly the same query as before, but this time I'm adding in, hey, I want that atomic grouping for that 0 to 9, 0 or more there. What do we think it's going to do? Well, it's false. It's false because it took 1 to 9. It did not leave 2 for that last part of the regex. So I can, if I want, make it possessive over its default behavior being willing to give back if there was something specific it wanted. So as you can kind of see, I can really manipulate the behavior of this. Again, the reason it didn't give up characters for this 0 to 9 here is it had no need to. This was, hey, if there's 0 or more, I'll take them. But it didn't need any of them. So just by default, it's greedy. It takes everything it can. If I change this, let's actually go back to this for a second. So remember, it took them all. If I change that 0 to 9 to a plus, remember plus means 1 or more, and I run it again, notice it did give up 1. It only did 1 to 8. So even in this greedy scenario, it was still willing to give up to make the regex successful. It would do the backtracking. That was the whole point of this. But this didn't actually need anything, so it just took everything it can. That's its behavior. That's why it was willing to give up when I needed to. But that possessive, that atomic grouping, it won't give it up. It will just take everything it needs. Now, there are other scenarios we may have where we have some pattern we want to match, but maybe it has to be preceded by something or it has to be followed by something. A price. In the United States or in England, it's the dollar or the pound sign and the price. In Europe, it's the price followed by the euro symbol. So sometimes I need it to be preceded by something. Sometimes I need it to be followed by something. So we have this concept of look ahead and look behind. So if I start with the US, dollars. A cheese pizza costs $, $10.99 today. So what I want to do is I want it to be one or more decimals. So I'm using /d plus. Remember, plus is one or more. But what I'm saying is, do you know what? I'm going to combine this with a look behind. Behind the pattern, I want to see $1. So I'm having the idea of, okay, my group, question mark, left arrow, and then equals, so that I'm going to define the pattern. Remember, $, is a special character, so I have to escape it. So it's \$. So I'm actually looking for the character $, not the behavior of $, what this does in regex expressions. So my look behind is question mark, left arrow equals the $, character. So I want to see the $, character ahead of one or more decimals. So if I execute, I get a match, and my match is 10. Well, okay, that worked, but it missed off the .99. Okay, it missed off the cents part. So then you can start playing around with it. For example, well, okay, what I'm really looking for then is optionally. So it could have 0 or 1. It may not have cents. It may just be $10. Or it could be $10.99. So what I'm now going to do is with 0 or 1 of a certain group. So I use question mark for 0 or 1, remember? So it's 0 or 1 of this group. And the group is the decimal character, the period character. Have to escape it because that's a special character in regex. So \. And then 2 decimals. So decimal /d. And then I want explicitly 2 of them. 2 cents, 99 cents. So it's 0, 2, 50, 99, whatever that is. I don't have to have that. But if I do, that's the format it needs to have. So now if I run it again, true. So now my match is, yep, $10.99. So it did match it. But if it wasn't there, it would still match as well. Now, I don't actually want to capture the 99 cents. So I can make it a non-capturing group. To make it a non-capturing, we just add question mark colon to it. So I'm adding to this group question mark colon. Nothing else changes. It's still a group. It still wants 0 or 1 of them, but it's not going to bother capturing it out, so I get a slight performance. So I don't care about it, but I just want to define it as a group as part of my logic. I can make it non-capturing to improve my performance. So if I run this again, look at my matches, there's not a match for the cents anymore. So it was still a group for my logic, but I don't capture it. So I'm making my code more efficient. Likewise, I could do a negative. It means I shouldn't have a pattern before. So a cheese pizza costs €10. Well, look at my matches. It worked still. Why is that? Well, what was my logic? Remember, I didn't expect this to work. I was expecting this to fail. Well, it still worked because what was my pattern? And this is one of the key things about regex. Sometimes it won't do what you think it should do because you've not thought it through. So I had €10. Okay. My logic is I want decimal plus. So 1 or more decimals is my successful match. And it should not be preceded by the euro symbol. Well, 0 is a decimal, and it is not preceded by the euro symbol. So you can start to see, okay, I have to think these things through. And that's what it matched on. You can see it matched on 0 because my logic in the regex wasn't complete enough. Euro 10, sure, the 10 doesn't match. But if I look at the 0 on its own, that's a decimal and it's 1 or more, so it matches my rule, it's preceded by a 1. Fantastic, regex worked. So I have to then maybe look at the whole word. So I then use the /b. If I use the /b, then it's false. Because now it's looking at the complete word, the euro 10. It's like, that's no good to me. Because there's a euro in front of the decimals. And it still works even with my 10.99. If I look at the whole word, because again, there's white space, so $10.99, I'm still good. Then, of course, there's the look ahead pattern. Hey, I want to now see it ending in something. So if in the euro case, it's 10 euros, I've got my 1 or more decimals, and then after it, I want to see a euro character. And that's true. And there we can see it. If I want to also capture that euro character, well, I just put it in a group. It'll be a separate capture group, but then I can actually use it. And likewise, I can use a negative look ahead. So exactly the same thing I'm using, just like we do in most coding logic. When I use that idea of an exclamation mark, it makes it not. So not followed by a $sign. Well, once again, we have that same problem because it was just a decimal, not followed by a $sign. Well, sure enough, 1 was not followed by a $sign. So once again, I have to put it in a whole word, and it does what I want it to do. So I'm just trying to stress that point that when we create these regexes, really think about the complete pattern you're trying to find and what you want it to do. Because by default, it may not behave exactly as you're expecting because you're not really considering it's just following what you tell it to do. You might in your head be thinking, hey, I want you to check on the whole pattern, the whole word. If you're not told it to do that, it's only going to do what it's instructed to do. So make sure you do consider all of the different scenarios. And there are other special characters. There's a nice little actual cheat sheet out there that I would kind of recommend to have a look at. Let me just open this up quickly over here. I'm actually going to show you a little some tools in a second. So this goes through all these different things. So hey, sort of the dots, the /d, any digit, uppercase D, any non-digit. So a lot of the things I showed you, it was like a lowercase. The uppercase is the inverse of that. So if a lowercase d is a digit, uppercase D is the inverse of that. And then we saw the W, any alphanumeric. Uppercase W is not a word character. S, any single white space. Uppercase S, any single other than white space. Tabs, carriage return, line feeds. So here we can see kind of that backslash. The special characters over here. Assertions. Here we talked about kind of the up arrow, the dollars, /b for the word. Non-word, uppercase B, again the inverse. And then the other types of look ahead, negative look ahead, look behinds, the groupings, the ors. There's a whole bunch of things you can do. We covered most of them, the various types of quantifiers you have. There's all different things you can leverage as part of this. So again, links in the description below. And just as an example, so I use regex for scraping. I create like a weekly newsletter I send out to my customers about the Azure updates. So this is an example regex I have that I use to scrape the documents. And it's really not very complicated when it looks very like, what are you doing? So I'm looking for this particular set of characters, just regular characters. I'm looking for this tag in HTML, div class column small 12. And then what I'm saying is any character lazily, so 0 or more, so the asterisk question mark, so lazily any character between that div class tag and the start of this div class row column. So I'm basically just getting all of that. I'm getting up to this. I want it to be, this div class row needs to be within a div class column. Is what I'm trying to do. And then I want to capture, so it's in a parentheses, any character, S or uppercase S, lazily again. But this I'm actually capturing, so I've got the parentheses around it, up till a closing /div. So all this really does is capture the text that I can then use elsewhere between this div class and the ending /div that's part of this other tag. Now, depending on the language you were doing, it may have like a parser for XML or JSON or whatever it is you do. But sometimes just these regex things are really nice to just go and capture the thing you want to do. So this file is there. You can go and play, try and create some of your own scenarios. I wanted to show two little graphical tools that are out there that are actually really nice. So the first is this regex learn. So regexr.com. You type in your regex expression at the top, and I've got my cheese pizza, and then you type in your text. And it's showing you where it matched. So it matched on the 1099. You can see it exactly here. It's showing me, hey, yeah, you matched. And then it breaks down your expression to all the different parts. And it's showing me in the tools what are the meanings of each of my different elements. So remember the whole point was the quantifier match between 0 and 1. So that was the question mark. Then we had a group of the character dot and then 2 decimals. But that was optional, 0 or 1. And then we had, oh yeah, it must be preceded by the character $, so we escaped it, and then some decimals, 1 or more. So we can see that's how it matched. So as you're experimenting, this is kind of a nice thing, and it was warning me that this positive look behind is not supported by all things. So not all browsers. If I try to do this in JavaScript, for example, this may not actually work. It doesn't like that positive look behind. Another tool, it actually puts it graphically. So I did the same expression, and then it shows you graphically that logic. And notice I had to change it to Python. If I did JavaScript, it doesn't understand that positive look behind. So I changed it to Python, and then we can see it working. It's showing me that, hey, preceded by a certain number of decimals, and then optionally, because it could jump over it if it wanted to, period, 2 decimals. So this is a nice little graphical view. And this one even has a cheat sheet as part of it. So this site actually has a cheat sheet you can go and look at to maybe help you with your coding. But this is nice that it visualizes the things you're doing. So again, if you're struggling, if it's not doing what you think it's doing, you could always paste in your text and then paste in your regex. It will visually show you your logic. So maybe it's like, oh, okay, I've got the bracket in the wrong place. Or, oh, I'm missing this. Or this is why. This might actually help me debug what you're doing. And you can even kind of move the start and see where it might fail or succeed within your actual string if you start messing around with it. So you can kind of do those different things. So there you go. So those were some of the things I really wanted to show, and that's regex. Again, the whole file's there. Go and play around with it. It's really not that complicated when you start to understand what some of these special little characters are doing. It's giving you the choice of things, start somewhere, end somewhere, certain iterations. It's optional. Check for something in front of, check for something at the end of it. But yeah, I hope this was useful. Again, you can use this in so many places, so it's so powerful. Be efficient in your code. Don't capture things you don't need to. Remember, I can make it non-capturing groups. But yeah, I hope that's useful. Until next video, take care.